We're looking at sketching cubic graphs today. So remember, a cubic graph, the highest power of x is a 3. The highest power of x is a 3. And they do come in different forms, so you do have to be a little bit careful here. But what you've got in front of you right here is the basic form of a cubic graph. And that cubic graph that you're looking at is y equal to x cubed, all right, or y equal to negative. So the negative changes the direction of it, but basically that is your basic graph over here, y equal to x cubed. So you can see that it's oscillating there through the origin being 0, 0. So here is the format that we're talking about today. It's almost like turning point format for a quadratic, but instead we've got a 3 there rather than a 2. This a value is your dilation, so it's making it narrower or wider. And of course, if it's a negative a, then we end up with a graph looking like that. All right, where the graph is oscillating there, see there at the origin, we call that the point of inflection, which is this bit down here, the point of inflection. So it's changing. If you think about the gradient there, that's negative, negative, negative. At that particular point, it's 0, and then it's negative gradient again. So it's not going back up again like it would for a quadratic. Same thing here. Okay, we have a positive gradient all the way up, 0, and then it becomes positive, positive, positive. So the other thing about this format is the translations. And again, it's like the translations for a quadratic. Here, this h is the translation on the x-axis. Here, the k is the translation on the y-axis. So why don't we have a look at some examples now to see how we'd go about sketching these. The graph of y equals x minus 2 or cube plus 4. Hopefully you can see that it is in that format, x minus h cubed plus k. So straight away we can read off that point of inflection. That's the point where the graph oscillates around. So let's think about the trend of this graph. All right, is it a positive or a negative there? Well, it's a positive, which means that our graph is going to look like that. Okay, so always visualize what you might end up with. Now, point of inflection is pretty easy to read off. It's like reading off the turning point for a quadratic. So here, our point of inflection is when x is equal to 2 and y is equal to positive 4. So remember, it's always the opposite to what's inside the bracket. Well, we've got a few bits of information, but we still haven't got enough to sketch our graph. And as usual, we need to find x and y intercepts if they exist. So let's start off with an x-intercept. We let y equal to 0. So let y equal to 0, you get 0 equals x minus 2 all cubed plus 4. All right, let's bring that 4 across so that we can get the x by itself. All right, now we've got x minus 2 cubed. The opposite to squaring something is the square root. The opposite to cubing something is the cubed root. So to bring it over the other side, it's the cube root of minus 4 is equal to x minus 2. And then let's bring that 2 across. So I've got the cube root of minus 4 plus 2 is equal to x. Now remember, you can't take the square root of a negative number, but you can take the cubed root of a negative number. So what we've got there is fine. If you were to work that out, even though that's a nice way to leave it, that's an exact value. If you were to work that out on your calculator, 0.413 is the approximate answer there. And the only reason why I've done that is so that I can, pretty much work out where it's going to be on my axis, but I would label it with this bit here. So my coordinate is 2 plus the cube root of minus 4, so you can write it that way or the other way, doesn't matter, comma 0. That is my x-intercept. All right, there's another point. Do we have a y-intercept? Will it cross the y-axis? Let's have a look. So let's try that now. Y-intercept, we're letting x equal 0. So you get y is equal to 0 minus 2 cubed plus 4. So substituting in x equals 0. And so you get y is equal to minus 2 cubed plus 4. Well, minus 2 cubed is minus 8. And minus 8 plus 4 is equal to a negative 4. So my coordinate there is 0, negative 4. So then you go ahead and plot those points on your axes. Remember, graphing is extremely important. There are marks given for graphing. So I've plotted 2, 4. I've plotted the cube root of negative 4 plus 2 there, and 0, and 0, negative 4. Now it's a matter of being able to graph it. Now remember, the oscillation point, and I'll do it in a different colour so you can see, the oscillation point is here. So at this point here is where it should be oscillating. So it's going to go up that way, kind of down, and then down through that point there. So this is the point here that you should be oscillating around. So remember this when you are graphing these questions. All right, another example, y equals x plus 1 cubed plus 2. Okay, you should be recognising that it's in that format. Okay, so it's like our turning point format, but it's for a cubic. We know here the trend of the graph because this bit in front of the a value is positive because a is 1. So our graph again is going to look like that. All right. And our point of inflection, POI, is negative 1 and positive 2. All right, so I've plotted that point on our axes and I'm going to continue on. Now, again, I need some extra points to sketch it, so I'm going to find my x-intercept. How do I find that? I let y equal to 0. Let's substitute it in and you get 0 equals x plus 1 all cubed plus 2. Bring the 2 across. Minus 2 equals x plus 1 all cubed. Cubed root of negative 2 is equal to x plus 1. Cubed root of negative 2. Take away 1 is what x is equal to. So again, I'm going to work out an approximate answer for that so that I know around about where it is on my graph. So x is approximately negative 2.26. All right, that's an approximate answer. But the exact value is the cubed root of negative 2, take away 1, and 0. So yet again, you plot that point in, is your next point, and we'll find a y-intercept now. Let's see where our graph cuts the y-axis. So y-intercept letting x equal 0, and so you get y is equal to 0 plus 1 all cubed plus 2. Y is equal to 1 cubed plus 2. Anything, 1 to the power of anything is 1, so 1 plus 2 is 3. So 0, 3 is our y-intercept, which is there. Now remember, your point of inflection is this point here. Okay, it's this point here. So that's where the graph has to inflect around. So it's sort of going to go like that, around that point, and then down through there. And I know that you're using a pencil for your graphs and yours are going to look really good. Much better than mine, I'm sure. So let's try one now that has a negative in front of it. So again, it's still in the right format, y equals a outside of x minus h cubed plus k. So I can read out my point of inflection, but this negative now changes the trend of my graph. So my graph is going to go that way. Okay, that's the trend. So the point of inflection, okay, what's inside the bracket? It's the opposite, so it's 1, and we've got a minus 2 there now, so it's 1, negative 2. So plot the point and continue on. And we have x-intercept that we need to find. So we're letting y equal to 0. So letting y equal to 0, you get 0 equals, don't forget that minus, x minus 1 cubed minus 2. Now bring that 2 across and you get a positive 2 now, minus x minus 1 all cubed. Bring the negative across, negative 2 is equal to x minus 1 all cubed. And remember, we can take the cube root of a negative, so the cube root of negative 2 is equal to x minus 1. And now we can bring that 1 across, and you've got the cube root of negative 2 plus 1 is equal to x. And if you stick that into your calculator just to get a roundabout answer, or try to work it out yourself, it's negative 0.26. Okay, but the actual coordinate itself is the cube root of negative 2 plus 1, comma, 0. And if you stick that into your graph, it's when x is around about there-ish. Okay, and so you will label that, and we'll label that point in a minute. Let's go on and find the y-intercept. So y-intercept, we're going to let our x value equal 0, and so y is equal to minus, putting the 0, 0 minus 1 cubed. Just be careful with all your signs. So minus 1 cubed is minus 1, and minus 1 times minus 1 is positive 1. So positive 1 take away 2 is a negative 1. So my coordinate there is when x is equal to 0, y is equal to negative 1. Again, remember where your point of inflection is. Your point of inflection is this one. So this is where we are inflecting around that, like that. So your graph comes and inflects. And I'm going to do that again because it looks horrible. So it's inflecting around that point there. Okay, and then it's going to go up through those. So always put in your point of inflection first and then sketch your graph. And again, you are going to do a much better job than me because mine aren't looking great on this. But you get the idea there, I think. All right, don't forget to label your axes y and x and label every single coordinate that you have gone through.